In this lesson, we're going to look at the different types of bonds and how they work and why they work. So there are three main types of bonds in chemistry. There are covalent bonds, ionic bonds, and metallic bonds. We won't talk about metallic bonds at this stage. We'll focus on the ionic bond and we'll touch on the covalent, but it's not actually part of this course or assessed. Firstly, when we look at the basics of bonding, we've talked previously about electron shells, and you know that the electronic configuration is how many electrons it has in the outer shell. We know that these electrons orbit around the nucleus of the atom in its shells, so they're just doing loops like little satellites around the nucleus. Each atom's desire is to have a full outer shell, a full valence shell. That is the sole purpose of these atoms. They want full shells, they want to be stable, and stability for an atom is a full outer shell. In order to do this, for certain atoms, they will need to donate electrons or gain electrons to fill up this outer shell. Just like we talked about with that ride, the idea is that you are always running at maximum capacity to be most efficient. And the atom is sort of the same concept there. Given that they all want to have a full outer shell, but the only elements to naturally have one are the noble gases on the right-hand side of the periodic table here, this is actually why these things are so stable. So the reason that noble gases do not react with anything, do not bond with anything, and are just generally really boring is because these already have full outer shells. So things like helium, neon, argon, krypton, xenon are really boring elements. They don't react, they don't bond, they just float around doing their own thing. As a result, when an atom without a full outer shell comes into contact with another atom, it generally wants to either give up or gain its electrons. So it's like these two different carriages of the ride running into each other, and both of them, one has like 3 people hanging off the side because it's not enough seats, and the other one is missing 3 seats. So it makes sense that the people will jump off and join the cart with the 3 available seats. The valence electrons are the number of electrons in the outer shell. We talked about this previously. These are the ones that form the bonds. It's all about the outer shells. It's not possible to steal an electron from an inner shell. It's only possible to steal it from the outer shell. Atoms with a relatively empty shell still want to give up electrons. An example of this is if an atom has 1 electron out of a possible of 8, it'll want to give up that electron so its outer shell is full. We use the analogy of a ride. It makes more sense that if you've got 8 seats and 1 person, you're not going to try and find 7 people. You're just going to kick that 1 person off and run it without it. However, if you've got something with a relatively full shell, it'll still want to gain electrons. So if you've got 7 out of 8, then it's a lot easier to just find 1 more person, and that's what these atoms do. So relatively full shells will want to steal electrons, relatively empty shells will want to lose the electrons. An example of this is an atom with 6 out of 8 electrons in its outer shell. It'll try and gain 2 so that it is now full and it's happy. This is where chemical bonding comes in. Chemical bonding is the process of atoms sticking together to form a new substance. So for example, carbon dioxide or water, H2O. These are chemical bonds. The bonding is one of the most basic fundamentals of chemistry. It explains all the other concepts such as molecules and reactions. Once we understand what bonds with what, from the periodic table, we can figure out what sort of things that we can stick together, and we can predict what we're going to get as a result. It's quite powerful. This is the periodic table representation of the number of valence electrons. The alkali metals of group 1, which is this one here, have 1 valence electron, so 1 electron in their outer shell. The alkali earth metals of group 2 have 2 valence electrons. Group 3 has 3, and so on and so forth. So just like when we talked about the groups and periods, these groups are telling you how many electrons in the outer shell. So everything here has 1 in its outer shell. All of these are likely to give up electrons, because they've only got 1 in their outer shells. It's a lot easier for them just to get rid of them. Same with these, 2 electrons in their outer shell, likely to get rid of. Once we get up here, these are going to start to take electrons because we're 1 off being full, 2 off being full, and in this case, your noble gases are full. Ionic bonding is when one element donates an electron or multiple electrons to another so that both elements now have a full outer shell. So this process of sharing or donating or taking electrons is the ionic bond. This results in a positive and a negative ion. So between the two things, if one donates its electron, it becomes a positive ion. And if one receives the electron, it becomes the negative ion. Given that this now forms a positive and a negative, these are electrostatically attracted, just like north and south magnets or positive and negative electric charges. They're attracted to each other, they stick together, and this is what forms the ionic compound. So this is what actually holds them together. If we want to write the formula for an ionic compound, there's a few steps we have to follow. Firstly, we need to identify the cation. So which of these things is going to give up its electron and become positive? Remember, cats are positive, so this is the thing that donates the electron. We always write the cation first. So when we name whatever the compound is, the cation is the thing that we name first. Then we write the correct formula and the charge for the cation. Then we identify what the anion is, so the negative, which of these is gaining the electron. This is written last. So the positive cation is written first, the negative anion is written last in the name of the compound. Then we write the correct formula and the charge for the anion. We combine these two together, and this is really important, it should form an electrically neutral compound. So for example, if I had a +1 cation and a -1 anion, I combine these together and they cancel out, it's a neutral compound. I can do the same thing with a +2 and a -2, so on and so forth. The ratio should be the same. So they should cancel out their charges and have an overall neutral compound. An example of this, if I had a sodium, which I look at its electronic configuration, it's 281, and I had a fluorine atom, which is 27. I can see that sodium is going to want to give up this one and have a full outer shell. Fluorine is going to want to take one and get a full shell. So sodium is going to become 28. It lost an electron, so it now becomes Na+. Fluorine gained the electron, so it's going to become F-. These two will now join. I'll have an Na+ and an F-. These join to form NaF, and we would call this sodium fluoride. So the fluorine becomes an ide, and we get sodium fluoride. A couple for you to try. What happens if I mix magnesium and oxygen, calcium and nitrogen? Do exactly the same process, write the electronic configuration, figure out which will donate, which will give, how many, figure out what the ion symbols would be, put them together following the rules that we've talked about in the previous lesson, and write what they would be there. Covalent bonding. So remember, this is not assessed in this course. It's just for a bit of information, but we're not covering it in a lot of detail. So if ionic bonding is the sharing, the donating, or the giving of electrons, covalent bonding is actually sharing them between atoms. So rather than one donating the other, they both share to get a full outer shell. And we always share the electrons in pairs. So you can see from this picture here, carbon is sharing 2 with oxygen and vice versa. So they all have an outer shell, but they're actually electron shells of both atoms.
Welcome to Dogs Teaching Chemistry. Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell. Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by two atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.
One thing to note at this point when we talked about forming the ionic compounds is that you can see here from before, everything in these columns is likely to give up its electrons. So it's going to become the positive, so the cations. Notice where they are. All of these things are metals. So these are our alkali metals, and these are the metals. This is where we would find sodium, potassium, francium, cesium, all of these kind of things. So we can see that the metals are going to give up electrons. And this is an important thing. In an ionic bond, the metal gives up its electron, and it is the non-metal that takes the electron. So the ionic bonds are a bond between a metal and a non-metal. This is what we need to form these bonds. Remember that we always name this first. So if I had a sodium and a chlorine or something like that, like a chlorine gas, I would have a sodium chloride because the metal becomes the positive. The positive is always named first. A sodium and a chlorine becomes a sodium chloride. So notice that the non-metal name always generally takes on an ide or something similar. So chlorine becomes chloride, sulfur becomes sulfide, things like that. Oxygen's a little bit different. Oxygen can become an oxide. It depends on how many we've got. In general, if you had magnesium mixed with oxygen, it does. It becomes a magnesium oxide. This is how we name the ionic compounds.
Bye. Have a beautiful time.